We are going to decide, is Coach Taylor a good free throw shooter? Okay, so that is what is in question today. So Coach Taylor was a star basketball player in high school. That's not true. That's such a lie. Such a lie. I played volleyball. Okay. Where she was an impressive 80% free throw shooter. So in your own words, what does it mean to be an 80% free throw shooter? So what does that mean? Okay. So each free throw has an 80% chance of going in. Each free throw has an 80% chance of going in. Okay. If Coach Taylor takes 100 shots, how many do you expect she will make? Is this guaranteed? If Coach Taylor takes 100 shots, do you think she'll have a streak where she makes 10 in a row? Not likely. Y'all have doubts about me. That's not fair. That's not
It's 0.8. Okay, that's right. What is that? It's about
third down.
but she's not really close. Wait,
It's 100.
100 shots. So 1 in 10 chance, right? 100 shots. That's 10 lots of 10 shots. Total.
All right. So let's actually test this out. Okay. So we're gonna use the law of large numbers. Okay. Really quick. The law of large numbers, and you can put this on the back if you need to, or you can put this on the front, is simulated probabilities tend to get closer I'll pull it on the screen in just a second. Closer to the true probability. Okay, you can either put this on the back or you can just put it on the side, whatever helps you. Okay, so you simulate this over and over again so that you get the truest probability, right? Okay. So we're going to create the law of large numbers applet. We're going to use the applet to shoot 100 free throws and use the table to keep track of the results. Okay. So there's this cute little applet that does this for you. If it'll let me in. Law of large numbers. Okay. So 80%, right? This free throw simulator assumes me. Really makes the indicated percentage of free throws. The plot tracks the observed free throw percentage after each shot and displays the true free throw percentage as a solid line. Okay, so I'm going to delete all this junk. All right, so, oh wow, so I missed it, right? Okay, what if I did it again? Okay, I make it this time, plus. So I made 1 out of the 2 shots. I did it again, 2 out of 3. Again. Let's say I did 50 shots. Yeah. Let's say I take another 50 shots. What is it getting closer and closer to? Okay. So on your paper, when you fill in this little table, let's say I didn't make the first shot. What percent was made? Okay. What if I did make the next shot? Okay. What if I made the third shot? What if I made the next shot? What if I made the next shot? 80. What if I made the next shot? I'm sorry, the next 5. If I make the next 5.
No, this one. Then sign it. Don't talk about it. Wait, if we're at 10 total, if we're at 10 total,
Then it's 90 because I'm only missed 1, right? Okay. What about if I made the next 5? So I've missed 1, but I've made 14. So what's 14 out of 15? Okay. What if I miss the next 5? Right? So that means 6 out of the 20 I miss. Okay. What if I make the next 10? Okay. All right. And so on and so forth, right? Okay. Now, hopefully, as we're getting closer and closer to 100, it's getting closer and closer to 80, right? Okay. All right. So we're going to sketch that little graph. So I'm going to give you a second on your paper. Let me reset this. All right. So really quick, go ahead and sketch this on your graph. You don't have to be super exact. Just kind of get the rough picture. All right, ready? At the beginning, this is called the short run. And at first, it looks like I'm really good. Like if I walked out there and I shot that first basket and boom, like sank it, I look pretty good, right? And then all of a sudden, I stop being so great, right? Like I start missing, right? So this is really unpredictable average, right? Now, once we get to like this area, we're becoming more predictable. And this is the long run. Okay. There we go. All right, coming back in here. So what did you notice in the graph? Like describe that graph. Say it again. Okay. What are you gonna say? Okay. So lots of variability at the beginning. And tends toward 80% closer to the end. Okay. In the 100 shots, did Coach Taylor make exactly 80 free throws? Okay, so looking at our little simulation, did I make exactly 83 free throws? No. Okay. Why or why not? If I did this again, would I get the same results? No. I mean, it might be close, right? But it's not going to be the same results, right? So, no. And that's every random sample of 100 shots is different. Okay, and this is what we call sampling variability. Okay. In my 100 shots, did I have a streak of 10 makes in a row? Was there a point in time where I was like, yeah, I made 10 here? Yeah. Okay. Is that really common? No. Okay. I'm sorry. Yes, I did make 10, but probably not common. Okay. Based on the results, what does the probability of 80% mean? Okay. Here's our statement that you got to learn for this unit. You know how like last unit it was 4 and then having a conclusion with correlation, association, and causation. After many, many free throws, the percent plus of makes will approach 80%. And this is what we call long run relative frequency. Okay, so on your quick note, what we talked about so far is we talked about probability a little bit. Okay. We talked about long run relative frequency. Yes, you can shorten it if you need to. We talked about probability. We talked about long run relative frequency. So this is always going to be between 0 and 1. Okay. It's just like your grades. They're between 0 and 1. Now, if you change it to a percent, obviously. Okay. Short run is unpredictable. Long run is predictable. Okay. If I had something that was 0% chance of happening, what would be an example of a 0% chance happening? Huh? Right. Okay. So something like crazy, right? Okay. What about 100% chance of something happening? 100% chance. The sun shining. Okay. People? People dying. There's a what that got real dark. All right. Yes. Yes. Natural causes, etc. Okay. Yes, that is a true statement. That got real dark. Okay. So the other thing we talked about was the law of large numbers. Okay. We talked about law of large numbers. So again, simulated probabilities tend to get closer to true probability, right? So it's kind of like as we test this more and more and more, we're going to see the actual true percentage, right? Okay, so down at the bottom, I want you to go ahead and do questions 1, 2, and 3. It shouldn't take you very long. It's going to give you about 7 or 8 minutes. Okay, and then we'll talk about them in just a second. Okay, so you're doing problems 1, 2, and 3. Okay. Yeah. Yes.
Oh.
All right. Let's go. Let's go. Stop it. Okay. Choose a probability value to complete the middle column of the table. Then give an example of an event that may have this probability. So you're going to use the probability 0, 0.001, 3, 0.3, 0.6, 0.991. Okay. This outcome is impossible and it can never occur. Which probability will be put there? 0. And what would be an example? Sal, don't answer. You're not in here. Dang. Okay. Yes, David. Don't even. Ooh. Y'all are the worst. Okay. I'm gonna say rolling a 7 on a die. Okay. Huh? I mean, on like a standard die. Yes. Okay. All right. This outcome is certain and will occur every trial. 1. Okay, what's an example? So like if we're using dice, what would be an example of 100%? Okay, getting a number 1 through 6. Word. Okay, what about this outcome is very unlikely, but it will occur once in a while in a long sequence of trials. Stop, David. God. All right, it's very unlikely. So that's going to be 0.001. Okay. Now, what would be an example of that?
Rolling 5.
That would be wild. But could we really do that like in like 100 trials?
Yeah. Yeah, that's done. No, you guys look good. Nice time for the like for the bullies in a way that lanes like people live.
And it sticks on like a. Okay. Rolling a die and getting 5s in 5 5s in a row. 5 5s in a row, or it landing on its like side. So like you said, very unlikely. All right, the outcome will occur more often than not, but doesn't occur almost every single time. Well, what would be the number for this one? 0.6. Okay. And you said rolling an even number? Okay. Rolling a number 1 through 4. Okay. Let's talk about like the weather in Georgia. What is it known for? Humidity. But it's not humid every day. But it's like most days, right? So there could be an argument for maybe that. Okay. All right. Let's go ahead and do the next one. In the Wheel of Fortune, there is 1 out of 9, so 11.1% probability of spinning bankrupt on any given spin. Interpret the probability. Do you know what Wheel of Fortune is? Okay, so I haven't like lost touch with the past. Okay. All right. So interpret the probability. So this is the statement you are going to use for interpreting the probability. Ready? After many spins on the wheel of fortune, the percent of times spinning bankrupt approaches 11.1% in the long run. So what words do you need for this sentence? You need, after many, many, whatever the context is, the percent of times of whatever the context is, approaches whatever the percent is in the long run. Okay, so red is the words that you're going to use. The blue is the context. Yes. Yeah. I would just say like after an excessive amount of doing this over and over again. Yeah. Okay. Because many is just like less than 100, but multiple. Many, many could be a lot.
Is there like a
Copious amounts of simulations. All right. In 9 consecutive spins on the Wheel of Fortune, none of the spins land on bankrupt. The next contestant worries that he's more likely to land on bankrupt now because bankrupt is due. Explain why this thinking is wrong. Go ahead. Okay.
Because the likelihood isn't going to change depending on what things you do, because it's not like there's like a time that so like the likelihood is less, or the likelihood is more. It's the same likelihood, it's just can couple that happening. It's just like
Okay. So probability is unpredictable. Predictable. In the short run. And streaks are common. So like, let's say, go back to my basketball example. Okay. Back to the basketball example. I start shooting free throws and I just crush the first 5. Does that mean that I'm going to get the next 5? No, maybe my arm got tired, right? You don't know. Maybe I lost focus. Maybe I'm not that good. Yes. Sorry. Probability is unpredictable in the short run, and streaks are common. Okay. Okay. How many of like you got 2 choices. Coke versus Pepsi. You got to pick one. Don't give me the like, oh, I like this, but this. No. Okay. All right, Coke, Pepsi. Nobody cares. They may not care. Yeah. Okay. All right, so Coke, Pepsi. So water. Oh, okay, there it is. Okay. So yeah, they used to do these little like contests, and they were always like really weird because like I'd never heard of anybody ever winning them ever. So.
It's in moderate. Then you can change like something in there, and it's like, that's insane.
Yeah.
Like the animals have a this little chip thing.
Yeah.
But the people still have to like pay for like the water bill thing, but it's like huge, and I have like the water signs. Like, no.
That's wild. Paying for water, yo. You can stay in a mansion, but you gotta pay for the water. Yeah, so a lot of people don't realize that like if you go on like The Price is Right or you go on Who Wants to Be a Millionaire, like half of that's gonna go to taxes. Like you get $1 million, great. Half of that's gone. So, and the other half probably isn't gonna stay long either. So Pepsi ran a contest for their 20-ounce bottles of soda. Some of the caps say, please play again, while others said 20-ounce, get one free. Pepsi advertised a promotion with the slogan, 1 in 6 wins a prize. Miss Gallus's statistics class wonders if the company's claim is true. To find out, all 30 students in the class go to the store and each buy a 20-ounce bottle of soda. 2 of the 30 students get caps that are winners. Okay? So, how many winners would you expect to get out of the class of 30? Why?
1 6 chance. 5 is 1 6 30, I guess. How big is that?
Okay, so you said if there's 30 kids in a class and you are a 1 out of 6 chance of winning, you're gonna have 5 winners. Is it guaranteed? Not guaranteed. Hey, what's up? All right, go ahead and look at. All right, so does the class result give convincing evidence that the company's 1 in 6 claim is a lie? We will perform a simulation to help answer this question. We will assume Pepsi is telling the truth. If they're telling the truth, what is the probability of getting 2 or fewer winners in a class of 30 purely by chance? Let's find out. Okay, what could we use to model a 1 in 6 probability? Okay, so rolling a die. Assign certain outcomes to losers and winners. List them below. So if I was doing a 1 out of 6, what number do we want to be a winner? Not 7. What? Okay, so 6 is going to be winner. Okay, and 1, 2, 3, 4, 5 is loser. Boo. Okay. All right, so we are going to roll a die, and we're going to do it virtually because I need to go buy dies anyways. Roll. Okay. Virtual dice roller. What a day we live in. Will it really? Yeah. Math. Okay, do it again. 30. What? I learned so much today. Okay. So, how many of them won a prize? So we're looking for the people with 6s. 1, 2, 3, 4, 5, 6, 7. 7? Yeah? Okay. So going back here. So how many won? 7. Do another trial of 30. How many won a prize this time? So we're going to do it again. This is so cool. Let me live. All right. 1, 2, 3, 4. Yeah. Okay. There we got 4. Plot the number of prize winners for each trial of 30 onto the board. We're gonna do it as a group. Hey, can y'all pull up a simulator? And then you can type in 30G6. Yeah. Okay, so try that. Everybody's gotta do it, because otherwise it don't work. All right, here we go. 1 on 10, 3 on 9, 2 on 8, 2 on 7, 1, 2, 3, 4, 5, 6, 7 on 6, 7 on 5. 2, 3, 4, 5, 6, 10, 11, 12, 13 on 4. 8 on 3. 1, 2, 3, 4, 5. 5 on 2. And 1 on 0. Okay. So how many do we have in total? 49. Some of you. See? Skewed data. Just saying. Non-response bias, you. All right. So we got 49 in total. Okay. And the next question says, based on the dot plot, what is the probability of getting 2 or fewer prizes? Okay, so we're looking at from here down, right? Okay, so how many dots do we have there? 6 out of how many do we have total? Okay. 6 out of 49. So what percent is that? 12? Yeah, it's 12.2%. Did you see how we did that? Nothing crazy. So does it seem plausible that the company is telling the truth, but that the class just got unlucky? Or do we have convincing evidence that Pepsi is lying? Is Pepsi lying that there's a 1 in 6 winner? Okay, so it is plausible that Pepsi is being truthful. And I'll move that thing down in just a second. And the class results happened purely by chance. So the way we determine that is 12 bigger or less than 5%? Bigger than 5%. So is it statistically significant or not? Not statistically significant. So 12% is bigger than 5, so it's not statistically significant. All right, once you're done, flip it over. Okay, so we have talked about simulation. Okay, so a way to model the random events. So flipping it over. We talked about simulation, and we also talked about evidence for a claim. Okay, so on your paper, we learned about simulation. Okay, and it's a way to model random events. Such that simulated events, simulated outcomes. Okay. Simulated outcomes closely match real world. Okay, so an example of a simulation is going to be like rolling a die, a random number generator, a coin toss. Okay. We also talked about evidence for a claim. Assuming a claim is true, to find the probability of getting observed results or more extreme. assuming a claim is true, we're gonna find the probability of getting the observed result or more extreme. So fewer than or more than. So remember in our problem where it said 2 or less than? So that would be the extreme. Okay, now we talked about the fact that it has to be less than 5% to be statistically significant. So that you could have convincing evidence against the claim. Okay, and we're going to practice that. Statistically significant, I think, makes more sense in this unit than it did in the last unit. Okay, because now you're actually dealing with the numbers. So take a moment, do A through E. Okay. Okay. And then we'll chat about it. But take, like, actually, okay. So some people have wondered if the Wheel of Fortune wheel is fair. Okay. If it is fair, the bankrupt should occur with a probability of 1 out of 9. So what is 1 out of 9 in percentage? What's 1 divided by 9? It's like 11.1%. Okay. To test the wheel, Pat Sajak observed a random sample of 50 spins of the wheel and found out that the bankrupt was spun 10 times. Is this convincing evidence that the bankrupt comes up more often than it should? Okay, so really quick, what's 10 out of the 50? 20%. Is that more than 11%? Okay, so are we convinced? Not necessarily. So we need to do a little bit more research. So if the wheel is fair, how many bankrupts would you expect in 50 spins? So we would take 50, we would multiply it times 1 over 9, because that's what they told us here. And that would give us about 5.56 bankrupts, right? Does Pat Sajak have some evidence that the wheel is unfair? He does, as of right now, because he says 10 is bigger than the 5.56, like significantly bigger, right? Okay. The dot plot displays the results of 100 simulated trials of 50 spins. So each dot represents 50 spins. Explain what one of the dots above 12 indicates. So if one of the simulation of 50 spins of a fair wheel, I'm so sorry. There were 12 bankrupts. Okay, so if we did a simulation of 50 spins of a fair wheel, there would be 12 bankrupts. Okay, now keep in mind that Pat did this. He came in here and he said, I spun the wheel 50 times and I got 10. This was his result. Right? So, assuming that the wheel is fair, what is the estimated probability of getting 10 or more bankrupts in 50 spins? What is the estimated result? How many dots do we have over here? 4 out of how many simulations do we run? So that's going to be 4%. So Pat did an experiment and we're comparing it to that. We're trying to see, did this happen and can we repeat it over and over and over again? Yes, ma'am. So remember, each simulation is 50 spins. Each dot is 50 spins. Yeah? Okay. Now, does Pat have convincing evidence that the wheel is unfair? Why?
Significant value.
Okay.
It allows us to believe other than that.
that the wheel is messed up, right? Okay, so assuming that a fair wheel is used, there is only 4% probability of getting 10 or more bankrupts purely by chance. Because this is unlikely, that it has convincing evidence of unfair wheel. Okay, so assuming a fair wheel, there is only a 4% probability of getting 10 or more bankrupts purely by chance. Because this is unlikely, Pat has evidence of an unfair wheel. Okay, so just like what David said it's 4%, which is less than 5%. Then we can say this statement.